Am I actually live this time? Might be. Thanks, YouTube. This looks better this time. Wow. Good enough. Oh, I see. Well, those are fine. Should be good. Alrighty. Think we have the stream going this time. I'm just watching on my other screen to see what it looks like. It does not look like trash. Alrighty. We shall start. Welcome. It's been a little while since I've done video. So yeah, electrical age. This is still 1710, so it's not electrical age 2 yet. We're working on it, but figured, you know what, we might as well do a little bit of fun stuff. So why not? This is on the Lusty Lavender Electrical Age server right now, and this is version 1.16.7, I believe. Yep. A recent build, you might notice, September 13th, just a few days ago. And it adds some fun things, which we're going to talk about today. Alright. Now, this is still kind of a preview release, so some stuff doesn't quite have textures like this. And there's still more stuff in the pipeline, but we're getting there. I just figured might as well do some nice feature updates, so we're just doing a thing here or there. Major changes from 1.16.5 to 1.16.7 is we fixed the lamps, mostly. I think there's still a pull request out for some more fixes, but at least a start. And we have also added this new thing called a rotary motor. So the rotary motor is a lot of fun. Let me grab a couple of items that we will need. We will need these. We use creative cables for now. We need a tachometer. We need a joint. We need a joint hub. We need a generator, a shaft motor. Let's start with those. So I'm going to build this whole thing up one, and you'll see why in a minute. So we're going to build it like this. We're going to place a tachometer here. And then we're going to place a joint hub. Then we're going to place a section going this way. So we got another thing here, tachometer. We're going to grab a clutch and a fixed shaft. And those should be all we need on that side. And then we're here, we're going to have a tachometer again, another clutch, just a regular joint, and then we're going to have 1, 2, 3, 4, 5, 6, 7, 8 of these. Connect them together into batches. We're going to try and make these wires mostly equidistant. Mostly. Oh, that's not going to work like that. Let's do that. Close enough. And we'll take power off from this side. Gonna gonna do these like that. A clutch and another fixed shaft. I can make this look better. There. Fun fact, joint hubs don't really need to be placed on anything, they can just go wherever. That's the most pointless joint hub. Anyways, doesn't look too bad. And then this, we're gonna create a special thingamabobber. And then we're gonna have some shaft motors, a clutch, and a fixed shaft. Now, we're also going to need an electrical probe with current set to 30. Yeah, let's do something more like 5 and 5.01. And we'll have this run like this. Now what that'll do is that will do exactly what I didn't want. I want this like this. 0 volts. Actually, I will want to change it, but for the moment I'm going to leave it the way it is. Actually, no, I'm going to put it back. I need some stuff first, though. Let's grab iron clutch plates and clutch pins. If you're not familiar with clutch plates and clutch pins, a clutch plate adds friction, and a clutch pin locks it, kind of, once you actually have gotten the speed to be about the same. So we're going to do that. I'm going to put them all in all of these. And I think we've basically got a test rig. I need a button. Oh, signal switch. Rotate it. You can press C and then right click to rotate, in case you didn't know. We're going to place these like this. That's configured. This we're going to set 900 and 1 and 900, and the purpose of this is to, if it hits 901, this clutch will slow it down. You can also use this to stop it if you want, so I could put like a signal switch here maybe, but I'm not going to do that at the moment. And what else? Oh right, this. So we're going to configure this guy right here so that if it's going over 800, it will allow this clutch to engage and lock. You'll see why in a minute. Okay, I think we have everything we need to actually start placing this nice rotary motor. So we're going to do the big reveal now. So the way you place this, place a block, and then you're going to place the rotary motor. You might want to stand back a little bit because it'll place stuff right here. Place it like this. And then delete this block. Unfortunately, there's no better way to place it at the moment. We're working on it. This should connect. I don't know why it isn't. Weird. I think I have located myself a bug. Alright. Yeah, I've located a bug. As I was saying. Oh, and I'm going to put a signal switch, not there, here. And I'm going to put a signal relay. A signal relay is basically just it disconnects this from this if it's engaged. So we can use it to enable and disable this from running. Okay, and we need a fuel source. So we're going to get a temperate fluid duct and a creative portable tank. And see how it turned orange? That means it pushes out. And we need fuel of some kind. You can use all sorts of different kinds of fuel. This thing's pretty okay with most fuel, I think. You can always check the Electrical Age source code for that. Or ask on our Discord. Alright, I think we are ready to start. So yeah, this is the rotary motor. I forget who modeled it, but thanks whoever did. In the future, we will set it up so that the fuel enters in the back over here, and this is where you have to provide a starting voltage to actually start it, like maybe 200 volts, maybe an amp or so, just a starter motor. And you would also control the signal from here or here, instead of this kind of wacky, put the fuel in here, place it here. It's really weird. One of these days we will fix that. But for now, this works. I want to have fun. So we have fuel, we have signal, we have shaft connected. Let me just make sure these clutches all have pins and plates. Okay, we're ready. Time to press the magic button. That's very anticlimactic. Let's grab a probe. Hold that thought. I think we are going to need to rotate this, unfortunately. I did not realize how temperamental this was going to be. My apologies. That's not what I wanted. I want this. And this. And this. And place this. And run this cable around. Yup, connects, nice. And I think the problem is this fuel duct. Alright, so this is going to spin up a little slower than I want because it's kind of connected wonkily. But, well, it's because I have this longer shaft, because it's got to spin up the motor itself, these shafts, which all have mass, and then these up to these clutches. Oh, hi, Mr. Skeleton. Alright, let's try this again. Oh, it's been on. So what's happening here? Should have fuel. Maybe it just does not want to cooperate today. Oh, I must have misconfigured this probe. Oh, I never configured it. Okay, let's say 820 and 850. There we go. Let me make sure that you can actually hear this. Yep. In fact, you'll probably have a hard time hearing me. This is having a hard time spinning up. Oh, I think I know what's going on here. Welcome to bugs. Alrighty. I'm gonna add a flywheel over here, which should... Okay. That should improve the performance. Alright. It's almost up to speed. Oh, and the click means that the clutch has locked. And now we're up to speed. Solid. So this right here is basically, well, it's supposed to pull a constant current. It's not going to. But it puts a load on this. So, yeah, this is going to consume power. We can make it consume more power by changing this value. So we can make this pull 8 amps instead. It'll pull a minimum of 8, basically. And by looking at this throttle line, we can see that it's about 40 volts. So it's about 80% of the output is whatever this is drawing over time. So we could put another probe here and measure power. Measure up to, let's do 100 watts? Or 100 kilowatts, sorry. Put a little graph up over here for you. Power. 100. Change this to 0.05. And the units are power. Yep. Okay. Let's change the amount of flywheels on here. That should make it more stable. Yeah. All right. So we're drawing full power at the moment to get it to do what it's doing, but we also did just speed it up quite a bit. Oh, interesting. Put this to 10. That should clean up that. Okay, yep. And if we put a low pass on it, it should clean that signal right up. I'm going to put it to the right frequency. Is that cleaning it up? Yeah. Yeah, that works good. Cleans up this input signal a lot. Solid. So we're drawing 31 kilowatts, 31.6, and we're using how much percentage on the fuel? 31. So neat. So we can probably pull almost exactly 50 kilowatts out of this thing. So let's set this guy here for kilowatts of power instead. Yeah. Let's do 30 kilowatts as a minimum and 35 kilowatts as a maximum. Okay. We're pulling a little higher than what we should, but we do have a low pass filter. Okay, it's in that range. And how much throttle do we have? We have some throttle. So we're drawing 34.7 kilowatts of power, and we've got the voltage at 34.9. So yeah, we can probably pull a little bit more power. Let's change this value to 40 and 45. Okay. $41.6. Alright, so you'll notice that the efficiency is only 99.9. There's a very interesting power curve, and the most performance you get out of this is at around 800 rads per second. So we can draw more power, and until this shaft gets to around 800, we still have more power we can pull. So let's narrow the band a little bit here. Let's put this to 50 and 51 kilowatts. Okay, so we're pulling a little more, around 50, 51. And the shaft speed has slowed down to around 811. We're probably putting out almost 100% power. Yep. So let's actually start graphing this. Change this to percentage, 0 to 100, 0.05. Yep, it looks like it's been pretty solidly just floored. We're around 811. So we can still pull more power. Looks like we've got 50, 51 kilowatts, so we can still pull more. A little more, not much, a little more. Let's try 51 and 52. Okay. And 809, so we haven't lost all of the energy yet, but we're getting close to that point where this thing will slow down and it'll not be able to start up. So we're driving it into the efficiency curve basically. Let's see how this looks. Alright, yep, we're at 100% efficiency. If it actually says 24 millibuckets per second, then that's kind of where I think it's actually too much, believe it or not. Once it gets below 800, yeah, see how it's starting to drop off? It can't recover from that because the efficiency is going down. It won't completely stop though because this is now going to disengage. That's why you hear it clicking. So the extent of what this can draw is around 50 to 51. So not bad. 50 to 51 kilowatts out of this one motor. That's pretty neat. So to show you some of what we've been doing on LL with this, we've used it as a starter motor. You'll notice when it's not running, it doesn't make any noise, even if it's rotating, which is kind of cool. It's based on whether there's fuel being ingested or not. So if I throw fuel in here, it'll actually start to make noise. So this is like the starter. We've got some creative voltage sources connected to some shaft motors, and then that, and some flywheels, and a whole bunch of turbines and generators, and these all connect up to these grid transformers, and then we've got tier 2 poles. We're not drawing too much power off these at the moment because we haven't really gotten very far on this world, but yep. So that's kind of what's going on with this new feature. If you haven't seen these new motors or tier 2 poles, it's probably because you're running the official Electrical Age version. This version is a custom version that I made. I'm going to let this recover a bit. So we can actually, if I shut off the fuel going into this, it'll actually become completely silent. Yep, there we go. It's out of fuel. So that's kind of neat. And if I start applying fuel again, it'll warm right back up. And you can use these static shafts with a clutch, and it'll completely stop this shaft. And it's still trying to apply power from this shaft. If I actually stop this one, then it'll stop both. Cool. No voltage, completely safe to work on. Because now that we have the new versions out, if you try to modify these shafts while they're running, they'll actually, explode stuff. I have explosions off on the server, but if they were on, then you would explode tons of stuff. Cool. So this world, it's mostly people are playing in survival. I occasionally do things in creative, like build this and some other things. All the electrical poles so far in the world are creative. So we've got like these large grids that we're setting up. Thanks, Minecraft. So we've got like... So this right here is a charging grid. It runs at 11 point something. Maybe it's 12.8 right now. 13.7. Okay, it's a little hot today. But this grid right here is designed to just charge these tier 2 poles at the transformers. I'm working on a bridge here in survival. So these here, this is a sample substation. So this right here will charge through this inductor the grid transformer before you connect it to the tier 2 poles, because if you connect the grid transformer right now, it'll just explode all these poles. So once this station is charged like it is now, you don't really need this once it's charged, but if it ever becomes discharged, it's nice to have. Once you've done that, you do a same kind of circuit as the charging circuit, and you allow people to connect on these. And this probe here is set for like 5 amps. We have cable pace set to like 3, so these cables can handle 14, but we're limiting how much people can pull out of them so they don't cause damage to the grid. and combine that with an inductor that's fully upgraded, and you get a relatively safe output point that people can connect power up to. And these poles might explode, but it won't explode any of the tier 2 grid stuff. So, and I had this connected to that, but I guess it got disconnected. What's the voltage on this? 55. Usually these are connected, but I just replaced these poles, so yep, same voltage, connect, bam. So they're saying you might not necessarily need to charge your grid transformers. On certain grids, you don't have to. On this grid, it's a pretty good idea. It really depends on how many grid transformers you already have on your grid. If there's not a lot, it's not going to matter. This grid already has like 6 to 8 of them, so it'll tend to explode the wires because it'll overcurrent them trying to charge the transformers. Real transformers don't actually have capacitance to them, but these ones do, so it's kind of unfortunate. FPS is better using the new engines. I don't know how the FPS would be affected by an engine, but that's for you. So another feature that we've been working on, T1 poles used to only carry up to 16 kilovolts. They can now carry up to 60 or so. I think 62 is the actual maximum. So these poles can now carry higher voltages because we wanted to have them inside like these underground tunnels, so it's easier to move power underground and you don't have to look at it, even though the tier 2s look nice. Sometimes you just want to be able to build things without having the wires all over the place, and sometimes you're building in mountain areas, and it's much easier to be able to move power underground, out of sight, out of mind kind of thing. So this is our work in progress. We're going to have some Railcraft routing stuff with open computers, I believe, and then power down here. And then the level above here, we've got like a subway set up. So we've got subway stations where you place your cart, hop in, shoot off to wherever you're going. So these are all world edited. I should mention that these were all world edited without the electrical age components. The electrical age components cannot be world edited, but if you do it before you add the electrical age stuff, it's usually safe. Just make sure don't have any electrical age stuff in what you're world editing, because they're not compatible, unfortunately. And there are no intents to fix that in this current version. In the new version, we might fix it, but we're not certain. We'll see. So, yep, underground power. And I will show you another substation that we have. So here's another substation. The power just goes straight up to these tier 2 grids again. But having the underground stuff is nice. And so here's another grid, and it looks like he's actually using it for his house, which probably has some stuff underground. Looks like he's got an experimental transporter and maybe some other stuff in here. Looks like he's got an ME system, some RF pipes. I don't actually see where his electrical age components are, but looks like he's using them somehow. I don't want to dig up someone's base. Hello. Yeah, so that's the grid, continues that way. This goes back towards the generation plant. Until the chunk loads in, it won't render these wires. That's why my chunk distance was a little higher. That's our charging grid again. Another feature I have changed is the tier 1s. You can run the wires up to 40 blocks instead of 24. These T2s, I haven't changed it. It's like 96 blocks. You can't really make it longer than that because you wouldn't actually be able to see the poles. They would, they wouldn't render in for a while. if you connect to a server. Generally, you got to keep it under 8 chunks of a distance, so I guess 96 was a sweet spot with how much people chunk load. So yeah, this is what's going on here and the new stuff. Trying to think if there's anything else I should show off. So there was a question, what new features are on the way? Well, I got to fix these regular features first. Like you can see, it's kind of got a rendering issue. Got to work on those first. And I do want to add some more features with regards to poles so that you can do things like mount them on the side of things. And mount them. I think I have an example over here, this subway station. Let's go down. I must have removed it. But the idea is that we would have some space to be able to put them, in the ceiling, like mount them on the ceiling, or be able to mount them on the walls. And another proposed idea was to be able to design your own larger size towers by building them out of blocks. Nope, we're still focusing mostly on Electrical Age 2, but figured we would do some stuff in the meantime. Yeah, so we want to be able to make it so you can make larger poles than these T2s. So basically we would provide you with like this large bracket-like thing, and then you could build blocks around it. So you could take, you wouldn't build it out of stone, and you'd probably make it look better than what I'm about to do, but you would basically mount it like this. You could have a large thing, and I'm going to do something that looks terrible, but to prove the point. So we grab, I just need a regular pole real quick. Let's rotate this. So this isn't perfect, obviously, but I'll give you a general idea of what we're thinking. So basically, the idea would be you can build your own towers, which takes a while, granted, but the ability to do so would be kind of cool. I need 4. And you could easily like world edit the towers before you actually place the wires on them. That's a possibility. So now that we've got this layer done, we can remove this. Obviously they wouldn't have these poles pointing out. Like it would literally just be this top portion shifted down. And then you can take your wires and you can have look something like this. So then you can have, you know, larger poles that carry more power. So we've got 1, 2, 3, 4, 5, 6 sets of wires. These can handle 15 times 16. So that's 240 times 6. So this is nominally a megawatt and a half of power on this many wires. If you actually do the maximum power, almost 2 megawatts on this many wires. So you'd be able to make your own design. It would still only be 50 kilowatts, but that's decent at least. And you can be creative with it. And those features will probably be in Electrical Age 2 whenever we get to it. It's T1 based off high voltage cables. The amperage is, yes, the voltage is multiplied by 16 if you're doing tier 2 and by 8, or no, 4 if you're doing tier 1. So it's like, I think you can do a little over 6, I think it's 80 kilowatts on a single one. You multiply it by 4 to get the tier 2, so 320 theoretically on the top, and then we were just doing 6 wide of that. So yeah, about 2 kilowatts on a 6 wire, 6 pair pole if you make your own. Oh neat, someone's got a house on the side of the mountain. That's new. Yeah, that's generally what's up here. Is there any other new features really going on? So we're going to fix this because there's still, you know, needs a texture, some other small things apparently. Bulb should now be fixed. So if I grab a couple of things here, let's grab those, let's grab some lights. I have also changed the way that lights work. They have different lifetimes now. Let's see if I can find one that's relatively short. 6 hours, 16 hours. So these are real life hours. This one will drop power faster. So this is the bulb that will last the least amount of time. So let's grab some voltage sources and some sockets. So, place some sockets. Let's place that in there. Let's place a 50 volt source and a wire and crash the server. Good stuff. Let's go fix that. This is like a feature of most Minecraft servers I run. This is... Okay. All right, let's restart the server. And hopefully it cooperates. No, jeez. Looks like we have some fixing to do. Alright, well, I guess that ends today's stream. Hope you enjoyed it, and back up your worlds.